Okay, these are the videos that match your textbook, sequences and series for section 11.1, and this is page 841. Whoops, sorry. This is page 841, and the problems we'll be doing in class. Okay, here are the objectives. You need to know what factorial means if you haven't seen it before. 6 factorial, or algebraically it's written 6 exclamation point. It's just decreasing numbers like 6 times 5 times 4 times 3 times 2 times 1. You also want to review the properties of sequences on page 837. There's quite a few. So if you want to know your properties, let me see how many there were. There's 8 properties that you need to review and look at those. You might want to look at them after we do this, so we can get started. The first thing, let's go over very quickly what the factorial thing is. I will show you where that is on your calculator, and at this point you can use your calculator, but at the same time you have to show me that you know what the concept means. So you just can't put in the calculator. For example, on this one, we're going to do one that says 9 factorial over 6 factorial. So we have 9 factorial over 6 factorial, and they want you to simplify that. So basically this is like 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And what happens here is these two cross out. So now you have to do is just multiply 72 times 7. And this number is 13. I'm looking at the answers here. So that equals 504. So in the future when you do this, instead of doing all this extra work, when you see something like this, what you want to do is just write it like this. 9 times 8 times 7 times 6 over, or what we're going to write it as, we can write this 6 as 6 factorial because we didn't finish it, over 6 factorial, and then those cross out. So you don't have to keep writing it. And this is acceptable in showing your process right in there. All right. Let's do another one that has, we have 3 factorial times 7 factorial over 4 factorial. So basically, for the 7 and the 4, I'm going to go all the way down and do 7 times 6 times 5 times 4 factorial over 4 factorial. Now what happens here is the 4 factorials cross out. Now I'm going to go ahead and multiply by 3 factorial, which is 3 times 2 and times 1. I usually don't write the 1, but I'm writing it now. And then when you multiply that out, you're going to get 1,260. Okay? So that's the factorial. Now let's get down to the more interesting stuff. All right, we're going to write out down the first 5 terms of each sequence. I'm not going to do 17 because it looks really easy, so I'll start with 19. And basically, they write the sequence like this. Whereas in a previous video, I just wrote S, I just wrote S for the list of the numbers. So what we're going to do is write out the first 5 terms. So we want ace of 1, ace of 2, ace of 3, ace of 4, and ace of 5 with commas underneath, all right? So I'm going to plug in 1. And so for the first one, I'll put 1 over 1 plus 2 is 1/3. So that's 1/3. Now plug in your 2. So you get 2 over 4, which is 1/2. That's your second term. Plug in 3. You're going to get 3 over 5. It's just 2 more. So it's 3 over 5. And then I'm going to plug in 4. Get 4 over 6, which is really 2/3. Just plug 2/3. And 5 would be 5 over 7. And I just wrote down the first 5 terms. I just plugged in my index number, which was here. That tells you which term it is. Okay, now let's do one with that's got the -1 in it. So I'm going to do 21. We have 20. It looks scary, but it's not really that bad because you're just plugging in numbers. We have 21, and that is, let me see it, -1 to the n minus 1, or plus 1 in this case, n squared. And we still have to write out the first 5 terms. So we need the first term, second term, third term, fourth term, and fifth term. So I'm going to plug in 1. So when I plug in 1, I get -1 squared times 1 squared. -1 squared is 1, and 1 times 1 is 1, so we just get 1. Now I'm going to plug in 2 here. So I get -1 times 2 plus 1 times 2 squared. So this is going to be -1 cubed is just -1 times 4, which gives me -4. All right, and the third term, I'm going to get, erase this, I'm going to get -1 times 3 plus 1, which is going to be 4, that's an even number, times 3 squared. Now all this is not 3 plus 4, but 3 plus 1. All right, all this does is if it's a even number here, that's going to make the 1 positive, and 3 squared is 9. So what you're going to see here is that this is going to oscillate from positive to negative. The next term is going to be negative because when we, when it's negative, when it's 4, you're going to get -1 to the 5th times 5 squared, and that's just going to give you -25. And what do you think the next one's going to be? 36. So that's all we're doing, and that's it. It goes back and forth. The next one, if we did the next one, would be what? -49. Then we'd have 8 squared, which would be 64. Then we'd have -81, and so forth. This part right here just changes the sign from each term. It goes opposite. Okay? Now, the next set we're going to work on is write down the nth term of each sequence suggested by the pattern. I hope you have your book open so you can kind of see, because you have to do your problems to match. So we have 29, and our problem set is 1/2, 2/3, 3/4, and 4/5. Now, when you notice this is you're looking for the nth term, so we want ace of n. And what you notice is this term on top is just 1 less than this term here. So you can write it as n over n plus 1. Because if this is ace of 1, ace of 2, ace of 3, ace of 4, then you'll get that. Let's do another one. Let's try 31. Let's see if I can fit it all in here. I'll write a little smaller. 31. We have 1, 1/2, 1/4, 1/8, and ... This should have been ... too. All right, so now what I do notice is I can write this 1 as 1 over 1. And what we notice is that we're just squaring the bottom term. So my ace of n, I'm just going to put 1, because that doesn't change, over n squared. Because if I plug in 1, 1 squared is 1. 2 doesn't work, does it? So this one I'm going to change because that's not working for me, because it didn't satisfy this one here. So what I'm going to do is write it as, I see this term here, definitely 2 squared is 4, 2 cubed is 8. But I need a 1 here. So the way I'm going to write this, my 1 was correct. And then I'm just going to write 2 to the n minus 1. Because when I do this, and we've already seen this before, if I plug in 1, then I'm going to have 2 to the 0 over 1. Well, anything to the 0 power is 1, and you get 1 over 1. The rest will follow. And you'll see 2 squared when you plug in the rest of these. This is ace of 1, ace of 2, ace of 3, and ace of 4. Okay, let's try 33. 33 is that oscillating one. We have 1, negative 1, 1, negative 1, 1, and they keep on and on here. Dot, dot, dot. Alright, so this one, all we're going to do is, we already saw this in the previous thing. I'm just going to write ace of n equals negative 1 to the n plus 1. Okay, that's what this negative 1 is, what causes the signs to change. Alright, and then when you plug in 1 here, 1 plus 1 is 2, and negative 1 squared, these would be even numbers here when you plug it in. Okay, so that one was what? 33. And let's go on to 35. See what we can do with this one. We have 1, negative 2, 3, negative 4, 5, and negative 6. Well, we see this oscillating thing. So since I see that oscillating thing, I know I'm going to write negative 1 to the n plus 1. And then I'm probably just going to write times n. Let's see. Yeah, times n. And when you do something like this and you're new to it, plug in the values again. Just write this as ace of 1, comma, ace of 2, ace of 3, ace of 4, etc. until you can till you get used to this notation with that negative 1. All right. Now we have the recursively defined formula sequences, and we have to write out the first 5 terms. You already did this on your communication grade, but it was in a different format. So you already know what it is, but we're going to get it on a higher level notation. So for example, on 37 we have ace of 1 equals 2, and then ace of n equals 3 plus ace of n minus 1. Now let me read what this is. It says the first term is 2, and the current term, the term you're looking for, is 3 plus the previous term. Okay, so when we see that, what we're going to do is let ace of 2, now if you notice, my n equals what? 2. That's my n, so that's what I'm going to put for this n as well. So ace of 2 equals 3 plus ace of 2 minus 1, which is actually 3 plus ace of 1. Well, what is ace of 1? Ace of 1 is 2. So 3 plus equals 3 plus 2, which equals what? 5. Now, we have to write out the first, we already know ace of 1, so we already have our first term. That's 1, 2. And now let's do our third term. Our third term is 3 plus ace of 3 minus 1. So that's when n is 3. And all you're going to do is equals 3 plus ace of 2. So ace of 2 was what? 5. So we're going to get 3 plus 5 equals 8. The next one we're going to let n equal 4. So ace of 4 equals 3 plus ace of 4 minus 1, which is 3 plus ace of 3, which equals 8, because ace of 3 was 8. It's right here. And again, you've done this before. It's just different notation. So you get 3 plus 8 equals 11. And one more term. We're going to let n equal 5. So a sub 5 really equals 3 plus a sub 4, which equals 3 plus 11, which equals 14. Now, clearly you can see this is just going up by 3 because it's just a sequence and it has a common difference here. So, but when you're showing your work on your test, you can't just assume. You have to show me that you know how to write this out. All right? Let's do another one. Let's do 39. We have 39, and it says a sub 1 equals negative 2, and we have a sub n equals n plus 4, no, plus a n minus 1. So we already have a sub 1, so what's a sub 2? Well, a sub 2 is just n. My n is 2 here. So we have 2 plus a sub 1, which equals 0. So we have 2 plus a sub 1 is negative 2. So let n equal 3. So a sub 3 equals 3 plus a sub 2, which equals 3 plus 0, which equals 3. Let n equal 4. If a sub 4 equals 4 plus a sub 3. Remember, always this means, if you want to read it, it's just the previous term. So my previous term was what? 3. So we're adding 3 plus 3, and we get what? 6. And next one is n equal 5. So a sub 5 equals 5 plus a sub 4, which equals 5 plus, my previous term was 6, which equals 11. So it's pretty easy. Let's see if I can find a more interesting one. Let's do 43. Okay, we have 43. And in that case, we have a sub 1 equals 3. And a sub n equals the previous term divided by n. So it just means the current term by n. So basically we already have a sub 1, so a sub 2 equals the previous term, which is 3 over 2. A sub 3 equals the previous term, which is 3 halves, divided by 3, which happens to be 1 half, because that's, right, this equals here 3 over 6. I can't squeeze it in, but anyway, I'll put it over here. That's 3 over 6. A sub 4 equals 1 half over 4, which equals 1/8. And a sub 5 equals 1/8 over 5, which equals 1 over 40. Okay, so that's how you do those. Now let's go to 51. I'm trying to get this all in one video so everything's all together for you. I don't know if I'm going to make it. 51, we have to write out the sum. So again, we've already gone over this. This is a summation notation. And this is going to be where k is 1. And we're going all the way to n. And we have k plus 2. So I'm going to write out the first few terms and then go to the end. So on 51, we're going to write, plug in 1. If you plug in 1, you get 3. And this, since this is a summation, we're adding it, even though the chapter is called sequences. This really is a series. So the book labeled it wrong, but anyway. 2 is going to go to 4. 3 is going to go to 5. Plus, you can keep going. I'm going to do at least 3 terms here, dot, dot, dot. And then I'm going to go to this last thing, and that's n. So I'm going to replace k with n. n plus 2. Go ahead and put that in parentheses. And that's all you're doing on that. So let's do another one of those. Let's do 53. 53, we're going to do 1 to n. And we have our formula is k squared over 2. So basically I'm going to write that out. That's going to be 1 half plus 2 squared is 4. So that's be plus 2. 3 squared is 9. That's 9 over 2. Plus dot, dot, dot. And then we're going to just write n squared over 2. Just like we did before. And that's all it is on that one. And let's see what else do we have to do. Express each sum using summation notation. So what we're going to do there is do 61. I might have to do another video. Let me try to go fast. 1 plus 2 plus dot, dot, dot plus 20. So basically what they want you to do is just write this in summation notation. So we're going to start with k equals 1, go to 20, and it's just going to be n. No, not n, but what? K. All right, let's do a more interesting one. Let's do 63. So 63, we have 1/2 plus 2/3 plus 3/4 plus dot, dot, dot 13 over 13 plus 1. So it looks like it's very simple. All we're going to do is write k equals 1 to 13, and we're going to write n over n plus 1. You can clearly see it here. This actually could have been written just as what? 14. This is just 1 higher than this one. So I just added 1 higher than my n here. And that's all you have to do. Let's do another one. Let's do 67. 67, we have 3 plus 3 squared over 2. And they wrote this out already nicely for you. 3 cubed over 3 plus dot, dot, dot 3n over n. So we're starting with k equals 1. And we're going to n, because we're ending on n. And I'm just going to write, let's see, 3. So it's always 3 to the n. And we're going to write what? K over k. Now basically what I did is I just wrote this last term, and I substituted with what? K. Okay? Now, on the last set we're going to work on find the sum of each sequence. So basically what I'm going to do, and we've already did this before, so I'll just do a few of these. We're going to have 71 where k is 1. I don't want to do 71. That's kind of lame. Let's do a harder one. Let's get into 75. All right, 75. We have the sum of 5, k equals 1, and we have 5k plus 3. So they want to find the sum of this, and remember the sum formula for this is n over 2 times a sub 1 minus a sub n. My n is 5 terms, and then I'm just going to do my a sub 1 is going to be 8, because I plug in 1, and plus 28 here, and then you can kind of add that up, 36 here, it's 36, 2 goes into 36 18 times, and 18 times 5 is something. So bottom line is the answer is 90. Okay, I'll try to do one more. I don't want my time to run out. Let's do one with the square in it. Let's do 77. These are all fairly simple. Just don't be scared of the summation sign. So we have 3, k equals 1, and we have k squared plus 4. I'm going to use my formula. Again, I'm doing it a little different than the book, but we already saw how to do the sum. So a sub 1 plus a sub n. So I have a total of 3 terms. And if I plug in 1, I'm going to get 5. And if I plug in 3, that's 9. That's going to be 13. So I get 3/2 times 18. 2 goes into 18. 9 times 3 equals 27. And that should be all. And you can do some of the evens. A good one to do would be 80. If you want, I could do 80 for you. Let's look at 80. I have a little extra time if I could hurry up. We have the k equals 1, and we have 4. We have negative 1 to the k times 3k. So I have 4 terms. So that's 4 over 2. My first term, when I plug in 1, is going to be negative 3. And my second term would be 6, correct? Let's see. If I plug in 2, that's 9. So that's just going to be 9. So you get 2 times 6, which equals 12. And I'm running out of time, so that's it for section 11.1.